.x.x, they're all the same addresses. So destination, only the destination address is fixed, while the others are moving, changing all the time. And in case of scans, again, we sort of sanitize the identity of the attacker. And if you see the destination address and destination port, these two are fixed, while the destination IP address is constantly changing from packet to packet. Okay. And also, one thing that you might notice here is that, that if you look at the destination address, it doesn't stay in a target network very long. It throws 7 packets or 5 packets to that network and moves to another network. So from that target, from the perspective of the target network, it'll see some strange packets, like 7 packets, and you wait some more time for more packets, but they won't arrive for a long time. So from the perspective of the IDSs or attack detection software, it sort of raises an issue, because if you have a very low bar, low threshold, then you will generate a lot of false alarms. So if you're worried about it, you raise the bar. But in that case, this kind of attack can circumvent it, because it doesn't have too many packets in an attack. Okay. Okay. So later on, fortunately we got our hands on some trace. It was the trace from 2 T3 links connecting Korea's Internet Exchange and United States. Korea Internet Exchange is one of the 4 major hubs for Korean Internet. And as to these 2 T3 links, they were half full at the time we collected the trace. So we could check our idea, the intuition, against this real life trace. Okay, it was collected over a 7-day period, and it amounted to 1 terabyte of data. We had this NDA, a non-disclosure agreement, with the KICS, and subject to that, we could analyze many aspects of the traffic. Okay. So this is what we got. Actually, when we got the trace, I let my master student to go ahead and draw a piece of trace using the 3 values observable from that KICS trace, and he reported to me saying that I see some lines, and immediately I realized that our intuition was right. The lines are text. Okay, so recollecting what we saw before, what do you think this is? A big rectangle. It's a DOS. And what are the lines on the bottom here? Actually, they are not entirely on the bottom. It's actually floating just above the ground. It's port 80. Okay, so since this is a 64K large, it looks like it's on the bottom, but it's not. So these are scans, and these are also scans. What about these vertical lines? They are, not all of them are port scans, but some of them are port scans. Okay, so actually you can see the attacks in one space. All kinds of attacks are plotted. Okay, and you can see the traffic going back and forth in the entire internet. The view oval from this particular location. Okay, so when we saw this picture, we realized that we got the right idea. Okay, and I guess we want to see. I want to see the entire days worth of this picture. From 9:35 a.m. to 5:20 p.m. It'll take about a minute. It's like an animation. Okay. Yes. Okay, so we'll see. We'll start from 9:35 a.m. And here you'll see the time index. So it's 11:29:35. Okay, so the time flows. So one frame is 1 minute, and each minute we have like 2 million packets plotted on the graph. So if you see, dots come and go, and it seems that the scans remain very long time. I mean, it goes on and on and on over a whole day. And you see that there are some vertical bars too. And all the rectangles are DOSes with destination port numbers also being filled with random numbers. So it looks like changing. Okay, I guess it's enough to see. Okay, so let's stop this and go back to the presentation. So why do we see so many attacks? Well, it was back in 2001, and the Korean government and the guys who were running the government network and in this exchange were not that security savvy. They were putting a lot of money to expand the Korean internet, so they were making all kinds of broadband connections here and there. But well, one analogy is that they were making highways, but there were no policemen. So a lot of hackers came into Korean internet and they launched the scanning attacks and DOS attacks, whatever you see in there. So this graph shows that how many attacks were there. So the x-axis is the time in the units of 10 seconds. So it starts from 9:35 and then ends at 4:20 p.m. And the y-axis is the number of connections observed at each time instance. And if you see at the bottom there's a line, and this is what we estimate the number of connections, the legitimate connections, okay, at each time instance. And if you see, if you see the top, you see this line with a lot of spikes. And we manually checked the trace, and we found that these spikes are DOSes. Okay, you saw in the previous animation that DOSes were coming and going. They were very short-lived DOSes. Okay, it was not like in a massive attack or anything like that. It's like a test run or some I don't know what that was, but it was very short, 1 or 2 minutes. So they come and go like that, and the bulk of the attacks are scans. Surprisingly, the scans, there are so many scans. And actually, the statistics shows that unfortunately, Korea at that time was the second after United States to generate the scan traffic. So there are a lot of scan traffic here. And another question is, okay, there were so many attacks in the trace, but why do they strike up? I mean, there are so much legitimate traffic there, okay, ambient traffic. But what is the reason that the attacks manifest themselves like that? Well, the reason is this: in that space, legitimate flows appear as a single dot. Think about their coordinates. Their coordinates are from their headers, and the headers, in particular, the source IP, destination IP, and destination port. They do not change over the lifetime of connection.